So hi friends, so today I will show you how to draw Morison element in Ansys Aqwa. So before to that, actually it's very important to anticipate the wave induced loads on the structure. So first of all, I will just so basically the method of wave induced load estimation is classified into two major categories, and in first category we have got the large structures like ships and semi-submersibles. Basically, these structures are very large, and they are capable enough to deflect the waves. So they basically lies in the diffraction regime. And secondly, we have got the structures like jackets and monopiles, and in some condition spar platforms also. And they basically lies in Morison region. And actually the or you can say that the section area at the cutoff water plane is very small, and these structures are basically transparent to the waves. And mathematically the above these two classification are obtained on the basis of diffraction parameter, which is also called as the scattering parameters. And this is your diffraction, or scattering parameter, which is the ratio of characteristic dimension of the structure at the cutoff water plane D, and L, which is basically the wavelength for that particular time period. So where D is the dimension of the structure at the cutoff water plane, and L is wavelength. So I will just increase the size of this marker. So this dimension of structure at the cutoff water plane means, suppose this is my spar platform. So this is my freeboard, and this is the draft, and this is your water line. So here that cutoff water plane area dimension will be the simply diameter of the structure. And suppose we have got some tapered kind of a structure like this. So here my suppose water plane is up to this particular tapered point. So instead of taking this as characteristic dimension of the structure, we have to take this particular dimension. So now coming to this diffraction parameter, if my D by L ratio is less than 0.2, then the structure lies in Morison regime, and if my D by L ratio is greater than 0.2, then structure lies in the diffraction regime. So I will just explain you by this example. So L is wavelength, and for deep water waves, empirically it is given as 1.56 into T square, where T is your wave period in seconds. So suppose you are doing the analysis for a wave period range of 6 seconds to 30 seconds. So what you will do, you will just calculate the wavelength by this particular formula. So for my 6 second, this wavelength will be 6 into 6, which will come near about, I'll just use my calci, 1.56 into 36, it will come 56.16 meters, and for 30 seconds similarly you will calculate as 1.56 into 30 into 30, so it will come near about 1404 in meters and meters. So from diffraction parameter we have got the length, wavelength basically, and suppose we are analyzing the structure which is having the dimension parameter, the characteristic dimension at the cutoff water plane as 10 meters. So suppose, so which is basically my spar platform, and you can consider basically we'll consider for time being we'll take is at that we are having the constant diameter. So suppose I am taking as 10 meter, so my D by L ratio will be 10 divided by, for first we will take 56.16, which will be 10 divided by 56.16 will roughly come near about 0.178, and this is a dimensionless property. And for 30 seconds I will just use as 10 divided by 1404, which is basically, which will be surely less than 0.2. So then also 10 divided by 1404, it comes out to be 0.007. So now you can see that this particular value is less than 0.2, and of course this particular value is less than 0.2. So now we know that our structure lies in the Morison region, and it will be basically dominated by drag and inertia force. So in Ansys Aqwa, this I will show you how to draw this one. So this is my basic project window which you will have when you open the Ansys software. So on the left hand side you have got the toolbox, and some analysis system modules are there. So you just double click on this hydrodynamic diffraction, and then you will have the tap down window kind of thing. In project schematic, you just double click on this geometry and you will end up in this design modeler, which is basically the hydrodynamic diffraction design modeler. So for drawing the Morison element, we basically use the beam elements, which are very common in a static structural. So I will just select as XY plane, and I will click on the option look at face or plane or sketch. So in this particular case, what I will suggest you that whenever you are drawing your geometry, because you always know what will be your draft and what will be your freeboard. So this is my 0, 0, 0 at this particular point. So whatever your freeboard is there, you draw your structure in such a way that that draft should come below this particular line, and your freeboard should be above this particular line. So suppose my structure is having total 60 meter of length. So suppose 10 meter I want as a freeboard and 50 meter as a draft. So for Morison element, what I will do, I will just go in the concept option. Wait a second. In create option, I will just go select the points, and then I will go for the manual input, and I will just put Z as 10 meters, which is basically my freeboard point. And then again I will go in the create option, I will select the point, and instead of that coordinate files, I will just put the manual input, and I will put this one as -50. So now you can see that I have got the 2 points. One is a 10 meter above the positive z-axis, and another one is your draft, which is -50 meter below the this 0, 0, 0 z-axis. So what I will do, I will just go in the concept lines from point option, and I will select these 2 points like this, and then holding the control button. So you can see that a green line is created. I will simply go and click on apply, and then I will click on the generate option. Now you can see that before it was 0 part and 0 body, and now it has converted into 1 part and 1 body. If you click on this positive section, then you will have a 1 line body option. So once you click on this line body option, then you can see that my particular line is highlighted in yellow color, and here in cross section tab it is showing that we haven't selected any cross section. If you click on this tab down button, then you will have the none as option. So what I will do, or basically we have to provide the cross section for a Spark platform. So you just go on the console button, click on the cross section, and then click on the circular tube. So basically offshore structures are hollow, so that's why I have selected the circular tube section. So here what we have decided that we will take the diameter as 10 meters. So I will just put the outer radius as 5 meters, and I will click on this generate option. So you can see that my a hollow circular section is created, and here we will use means I will not provide any thickness kind of thing, because for hydrodynamic dimension it basically depend upon the displaced volume. So if you provide the outside radius, then Aqwa will automatically calculate the displaced volume and displaced mass. So I will just click on this generate option here, and then if you are doing some static structural analysis, then this particular thickness value plays a very important role, because your von Mises and other, suppose we are calculating some other stresses, should be less than yield stresses, so which basically depend on the thickness of the structure. So for time being in hydrodynamic diffraction, this particular Ri or input radius doesn't means anything, so you just keep as it is, and then you click on the generate option, then you click on this line body option, and in cross section you just go and click on the circular tube, and then you click on the generate option. So you can see that that line body, it is converted into that green check color, and my cross section is assigned to my line, but then also nothing is shown in this particular graphics window option. So which is basically because you have to go in view option, and then you have to click on the cross section solid. So once you click on this cross section solid, so you can see that your Spark platform or your cylinder is generated here, and with a freeboard of 10 meters above z axis and a draft of it's exactly 50 meters. So in this way you can draw the Morison element or tube elements in hydrodynamic diffraction module of Ansys. So that's it. Thanks very much.